Ouch!
Hooray!
Welcome back to the channel. Back to the channel. Basic is just too slow. Machine code is the answer. Fasten your seatbelts.
Look at this data flow. Thousands of instructions racing forward, perfectly aligned, until they slam into a wall. They are forced into a narrow conduit, and the entire processing pipeline grinds to a crawl. This bottleneck is the defining challenge of 8-bit computing. There is no better testing ground to dissect it than the hardware of the Commodore 64. Most users initially interacted with this machine through BASIC. Because it is an interpreted language, it serves as an accessible logical brain for writing simple programs and managing the user interface. But that accessibility comes with a steep mechanical cost. During runtime, it reads the code, analyzes the syntax, and translates it to machine instructions, line by single line. If you are calculating a few variables, that process is fine. But if you attempt to execute intensive graphical operations or mass memory fills, that interpretation layer introduces fatal latency. The alternative is machine code or assembly. Assembly operates at the raw speed of the silicon itself, bypassing that translation layer entirely to talk directly to the processor. Effective system design bridges high-level logic control with low-level hardware execution. This diagram outlines the programmer's dual pathways. On the left, BASIC acts as a severe choke point, forcing data through a restrictive pipeline. On the right, assembly code uses direct processor communication, moving down a frictionless track for immediate execution. Historically, extracting data from the slow tube and injecting it into the fast track was a tedious manual operation. We are going to discard those legacy methods. Instead, we will deconstruct the hidden architecture of the parameterized SYS command to reveal how it forces high-speed data transfer straight into the processor's registers. In the early days, hobbyists bridged the gap using the poke command, which relied on mapping memory completely by hand. This diagram illustrates the problem. The poke command forces values into memory block by block. This creates severe material fatigue and is highly vulnerable to human error. If basic memory accidentally overlaps with machine code, data corruption is an absolute certainty. The professional alternative circumvents manual mapping entirely by using the parametric SYS command. This schematic breaks down a SYS command array. SYS 4096, 1024, 2023, 1. 4096 is the entry point, dictating the starting address. 1024 and 2023 dictate the operational scope, targeting the precise beginning and ending addresses of the screen RAM matrix. Rather than relying on thousands of individual memory writes, this array feeds a complete, targeted set of instructions directly into the execution command in a single breath. This introduces a mechanical problem. Machine code does not natively know how to read a string of comma-separated parameters sent from a BASIC environment. To bridge this gap without writing inefficient read logic from scratch, system architects rely on intelligence permanently etched into the Commodore 64's system ROM. This cutaway shows the translation bridge in action, utilizing a system ROM routine known as USMI, or take. When called, it initiates an automatic fetching cycle, reaching out to grab the very next 16-bit parameter waiting in the BASIC array. This blueprint shows how the hardware handles 16-bit data. Operating on an 8-bit architecture, the USMI routine automatically cracks the value, hexadecimal AABB, straight down the middle. It routes the lower byte directly into register Y, and simultaneously sends the higher byte to accumulator A. The USMI routine is the literal bridge. It translates a human-readable integer instantly into the raw physical states required by the processor's hardware. Bypassing the interpretation layer grants direct access to the 6510 registers, but it demands precise architectural discipline. Since processor memory is confined to a strict 16-bit space, there is a hard mathematical ceiling to the size of parameters you can pass. This graphic shows the system's automated guardrails. The maximum routing value is 65535. Exceeding this halts execution with an illegal quantity error. If the code expects more parameters than supplied, a level 1 warning safely blocks execution with a syntax error. Those are automated, polite safety mechanisms. But the real danger lies in where you aim those numbers. This diagram maps out the stakes. Routing parameters via the SYS command manipulates memory without a protective safety net. You must avoid the zero page, a highly sensitive area. and the system vectors, the central routing paths for the operating system. Directing a parameter into these red zones avoids polite warnings. It will instantly wipe your program, corrupt the OS, and trigger a total hardware crash. Efficient retrocomputing exploits symbiosis. BASIC handles high-level logic and interfaces. Machine code steps in for processor-intensive tasks, executing graphics at the 6510's raw clock speed. The parametric SYS command links them, transmitting precise 16-bit data packets without the latency of manual memory mapping. To verify how these pieces fit together, look at this final diagnostic challenge. Analyze the command string sys 4096 10000 33 10. If you investigate the memory map starting at address 10,000, deduce what output parameter 33 represents in the physical hardware. When you understand how to manipulate registers and construct these bridges between memory environments, you stop writing code like a hobbyist, and you begin directing silicon like a system architect.
I had a bezel keyboard, heavy as a door, 64K of magic, and I still wanted more. I typed in my command line, feeling like a king. Load star, comma 8, comma 1, and prayed it loads the thing. The screen was blue, the cursor bright, the tape was screaming through the night. Commodore 64, you're my pixel superstar, with your chunky little graphics and your SID chip from afar. Commodore 60, you were slow but never poor. You made us wait forever, then we came back for more. My joystick had one button. My joystick, one button, but I pressed it like a pro. Jumping over pixels in a world of green and gold. The sprites were square and funny, the music had that bite. The music had that bite. Every tiny loading screen became a Friday night. The floppy clicked, the tape would cry, but every crash was worth a try. Commodore 64, you're my pixel superstar, with your chunky little graphics and your SID chip from afar. Commodore 60, you were slow but never poor. You made us wait forever, then we came back for more. No Wi-Fi, no updates, no cloud account to sign. Just cables, keys, and patience, and a loading bar divine. No touchscreen, no drama. No battery, no drama, no battery at one. Just plug it in and type away, that's how we had our fun. Commodore 64, you're my pixel superstar, with your chunky little graphics and your SID chip from afar. Commodore 60, you were slow but never poor. You made us wait forever, then we came back for more. So boot it up, don't shut the door. We're dancing with the Commodore 64K, but dreams galore. Long live the Commodore 64.